So moving on to the first question, we have the energy equation for a reversible non-flow process can be expressed as delta Q is equal to du plus pdv, where Q is the heat transfer per unit mass, U is the internal energy per unit mass, P is the pressure, and V is the mass specific volume. This energy equation is not in exact differential form. It can be made exact differential by multiplying with the following integrating factor. See, we have been given this equation as delta Q is equal to du plus pdv, and it is given that this equation is not in exact differential form. So there is a general mathematical rule that if you have to convert an equation which is in inexact differential form to exact differential form, we need an integrating factor. Now for the given equation, delta Q is equal to du plus pdv, this equation is not in exact differential form. Now we have two approaches to solve this question. One is purely mathematics, and we will use very little concept of thermodynamics, and in the second approach we will use the concept of thermodynamics. So first we will move on to the first approach, which is purely mathematical. So if we look at this equation, the differential terms of this equation are du, dv and delta Q, and you can see that Q is preceded by delta, whereas U and V are preceded by d. So if a term of equation is preceded by delta, then it is in inexact form, and if it is preceded by d, then it is in exact form. So I can see that right hand side of this equation is in exact form, whereas left hand side of this equation is not in exact form. Now it is given in the question that this equation is for reversible non-flow process. Now from second law of thermodynamics, we know that for a reversible process, delta Q can be written as T into ds, or I can rewrite this equation as ds is equal to delta Q by T. Now this S is preceded by d, so it is in exact form. So if I divide this equation by t, I can make this equation which is in inexact differential form to exact differential form. So this is the first approach. Second approach is purely thermodynamic. We will use purely thermodynamic concepts. So again rewriting this equation as delta Q is equal to T du plus pdv. So we will again look at the differential terms. See, U is the internal energy per unit mass, and V is the mass specific volume. So U and V are thermodynamic properties. And properties are always exact differentials. Whereas delta Q is not a thermodynamic property, so it is in an inexact differential. So again using the second law of thermodynamics, which says that delta Q is equal to TdS, and I can write this equation as ds is equal to delta Q by T. Now this ds is again a property of a system which is popularly known as entropy, so which is again an exact differential. So from both approaches we got that if I divide this equation by t, delta Q by T, so I get an integrating factor which convert this inexact differential form into an exact differential form. So correct option from the given option is option number C. So next question, we have an air standard diesel cycle consists of 4 processes. 1-2 is isentropic compression, followed by 2-3 constant pressure addition, followed by 3-4 which is an isentropic expansion, and lastly process 4-1 which is constant volume heat rejection. Now T4 is the temperature attained at the end of isentropic expansion 3-4 before constant volume heat rejection. The constant volume heat rejection process is replaced by a constant pressure heat rejection process such that T4 is the temperature reached at the end of the isentropic expansion 3 to 4A and the state point 1 remains the same then. So we have been given in this question a diesel cycle consisting of 4 processes: isentropic compression, constant pressure heat addition, isentropic expansion and constant volume heat rejection. So let us draw this cycle first on a TS diagram to understand the concept of this question. Now process 1 to 2 is isentropic expansion. So this is a TS diagram and I can represent that process with a straight line since it is isentropic. So I can plot like this. Now process 2 to 3 is a constant pressure heat addition process, so which can be plotted like this. Now process 3 to 4 is again an isentropic expansion which can be again plotted by a straight line. Now process 4 to 1 is a constant volume heat addition process and it can be represented by like this. So I have 4 processes: 1, 2, 3 and 4. Now the question is saying, if I replace this constant volume heat rejection process by a constant pressure heat rejection process, keeping this point 1 same, and if the temperature attained is T4A, so what will be the position of T4A on this TS graph, whether it will go here or it will go here? See, that depends on the slope of this constant pressure curve. If the slope of constant pressure curve is greater than slope of constant volume curve, then I will attain T4A here. And if the slope of constant pressure heat rejection curve is less than constant volume curve, then I will get T4A here. So let us find this concept. See, from thermodynamics, we know that delta Q is equal to du plus PdV. Or I can write this equation as TdS is equal to du plus PdV. Now, since it is a constant volume heat rejection process, now for a constant volume heat rejection process, this goes to 0. So we are left with TdS is equal to du, or I can write this du as Cv dt. So I can write TdS is equal to Cv dt, or I can find dt by ds, which is the slope of a curve on a TS diagram, which is a constant volume slope, give T by Cv. Similarly, we have TdS is equal to dH minus of VdP. Now for a constant pressure process, this goes to 0 and we are left with TdS is equal to dH. Now I can write this dH as Cp dt. So I can find the slope of curve again dt by ds for a constant pressure process as T by Cp. Now we know that Cp greater than Cv. This is always true. Now T is same for both, so I can see easily that the slope of dt by ds for a constant pressure curve is less than slope of constant volume curve. So if the slope is less and I have this slope originating from the same point, then obviously this has a more curve and this has lesser curve. So this is theta 1, this is theta 2, and theta 2 greater than theta 1. So from the given diagram I can easily see that the slope of constant, if this line is replaced by a constant pressure heat rejection process, the slope will go like this and we will get T4A at this point. So from the given option, T4A will be less than T4. So option A will be the correct answer.